Hello, thank you, and thank you for turning up so early in the morning, so bright looking. I know it's the second day of the conference and you probably all had a big night last night. So I'd like you to get yourselves into a bit of headspace for me. I'd like you to pretend that it's 9 o'clock in the morning. It shouldn't be hard, because it is. But I would like you to think you've just gotten into the office. You've sat down, your office might be in your house, it might be at the office, it might be a coffee shop, it doesn't really matter where it is. But you've just sat down and you're thinking in your head, maybe I should get a coffee before I start working. And then your phone goes ding. It's the CEO. It goes ding, ding, ding. And the CEO is out on the golf course. They're having fun, they're out with their friends, and they've been talking up this new feature you've been working on. This new feature that is going to change the game. It is going to reset everything, and it is going to absolutely make them lots of money, so they want to brag to their friends. They pull out their phone, they go to stage.myapp.com, and nothing happens. The website's broken, or at least staging is. That's what he thinks. So the CEO sends you this message. Can you fix this? Can you fix it now? And you look at your phone, and you sigh, and you say, sorry, the staging environment is only available inside the network. It's not going to work for you, I can't change this. The CEO is flabbergasted, they're surprised, and you know that you're going to hear about this when they get back from this golf game. So you better go get that coffee, because that's going to be a hard conversation later today. Just quickly, my name's Klee Thomas. I'm a software developer. By night, I organise the Newcastle Coders group. I like a bright, loud print shirt, so you'll see me around the conference long before I get close to you. I'm part of the Auth0 Ambassador Program, and you can find me on Twitter at KLEEUT. I'd love to hear what you think about this talk or anything else, so hit me up. Today I will go a little bit over staging environments, a little bit over zero trust, a little bit over Cloudflare Workers, and then I'll bring it all together in a demo at the end. So staging. Got to talk about staging. Staging is your production-like environment. This is where you have something set up that is as close to production as you can get, so you can thoroughly test it. And it's important that it's production-like. You need staging to be in a way that you can't make excuses. Oh, that's just staging. It'll be fine when it goes to production. If you've got that set up, then you can't trust it, and it's no good. All that testing you do isn't worth anything. In this environment, we can test hard. We can go and push it until it falls over. We can find out what our limits are, so that as our company scales, we can deliver value to our customers without those big outages that we worry about. Here is where we can bring in external people to come in and hack the system. They can break it apart without actually exposing customer data. Staging is really important for testing, and it's important for review, because in staging is where you're going to put up the new terms of service and get legal to read over it and make sure that everything's okay and that you're not going to be accidentally giving away your product for free or breaching some bizarre law. It's where marketing can come in and check that your system and the marketing pages you're putting out matches the paper marketing that's going out later that day, matches the SMS marketing, so you're not actually sending out different messages. So staging is really important. But by virtue of everything that I just said, staging is also where you've got a lot of half-finished work. You don't want people just stumbling into staging because they might see that terms of service, and then that terms of service is now valid because you've published it out to users. They might see the financial reports before they go out to the ASX and expose you to a whole bunch of pain. So we need to make sure staging is secured there, because that pre-market information is valuable. It's valuable to your competitors, it's valuable to your investors, and it could mean the difference between your company continuing and your company falling apart. And finally, even if none of that's the case, everything is just exactly the same, if you have Google indexing you twice, you're going to get SEO damage. Google doesn't like the idea that there is 2 copies of the same website out there, so it'll downrank you and throw you away because it's like, oh, this is no good. You'll end up on page 2 of Google, and nobody knows what's on page 2 of Google because no one's ever actually been there. And you might say to me, but Klee, my website is entirely behind a login page. Everything is secure, everything's off from the public. And I will say, first of all, I don't believe you. Why would anybody sign up to a service that has no information about what it is or why you can use it? But even in the case that you are working on some weird back office application that nobody actually has access to, it's still important to protect it, because do you know what's not behind that login page? The login page. And at some point, you're going to have to test out that you have alert messaging for if the system's down to explain to people why they can't log in. You're going to have to check that that rebrain that's coming down the pipe is all set up and is all working well. You're going to have to make sure all this stuff is ready. And that's pre-market information, again, that you don't want just getting out there. But staging is more than that as well. I'm willing to bet that everyone in this room, in their staging environment, has seen bad passwords. Maybe they've optimized their testing at some point so they can log in and out of accounts really fast. So all the accounts have the password test12345. So it's really easy. You can jump in, jump out. Everyone knows the passwords. Everyone can test quickly. It's a really good workflow for the developers and the QAs. But that also leaves you really open to anyone who wants to come in and try and break into that environment, find out the information that's there. And it's always that possibility that you've taken data from production, real customer data, and maybe you've done some sort of little de-identification process over it, but in reality, it still looks really like real customer data. And if that data is extracted out by some script kiddie, dumped out onto Pastebin, then you're still going to end up sitting in Troy Hunt's Have I Been Pwned database, because that is real customer data that has been exposed and you have had a data breach. At this point, that CEO, while she was really unhappy that she couldn't play golf with her friends and show off your new app, she is also going to be really, really unhappy when she has to stand up in front of the media and say, yeah, we had a data breach, and it was because we just had bad practices. So we need to protect staging. But with everything that I've just said, you might think, why not get rid of it? Why not toss staging in the bin? Maybe we'll just go back to testing on our own laptops. That'll work well, right? Well, staging is important because staging is where we collaborate. Staging is where the marketers in their nice fancy clothing and their clean-shaven faces come and collaborate with someone who looks like me, who wears Hawaiian shirts and has a beard that sort of sticks out every which way. It's where legal come down in their Armani suits and talk to the developer wearing an NDC hoodie and says, okay, great, this is good, we can get this out. It's where our company can come together and collaborate. It's where we can do that testing that we can only do in a production-like environment. Staging is so important. We have to have a staging environment, but staging needs protecting because staging is important and it's a vulnerability. So we know how to protect it, right? It's easy. We just throw up a robots text. Now, it says, don't go to staging, and Google looks at that and doesn't index staging. Now, you can't find staging by Googling, and all of a sudden, everything's good, right? And that really relies on the fact that you trust Google. You trust Google to not look past that robots text and index things anyway, but just not show it to the customers. relies on the fact that you trust that Google is the only bot out there scraping the internet and that there's nobody else just looking through to find some vulnerable system. And I don't trust Google. I definitely don't trust there's no other robot out there. So we know the next answer, right? We're all in the office. We build a big firewall. Everyone over that side is trusted. This side is trusted. Everyone over that side is untrusted because the people in the office are fine. We know they're there. They've had to badge in, they're secure, and we'll just let only people in the office access staging. That works really well. Google's on the outside. Our script kiddies, they're on the outside. They can't get in. Great. Staging is protected. Everything works well. We can sleep well at night. But then you've got that one developer who has a few reasons why they need to work from home. So we make a VPN server for them, we let them in, and that works well enough. Then we find a few cloud services, some other organizations we want to work with, and they need access as well, but can't come in through the VPN because it's a SaaS product. So we add their address to an OL list, and we punch a little hole through the network. And that gives them access to staging. But the script kiddies, the Googles, they're still on the outside. They can't get to staging. Everything's okay. But then COVID happens. And all of a sudden, the number of people on the untrusted side of the network is getting really big. All of our teams, all of those marketers, all those developers, all those lawyers, they've had to work from home. So that VPN server, it's gotten big, it's gotten expensive, and it's fallen over a few times, and it's costing the company money. And those SaaS services are still there. They're still coming in. We've got more and more of them, so we're adding more addresses to this allow list. But then, because COVID did funny things for tech, all of a sudden our business is growing. It's getting bigger fast. And we can't hire fast enough because there's just not enough developers out there. So we go and we bring in some consultancies, maybe a security consultancy, a testing consultancy, and another dev consultancy. And they're all coming in from their private network, so there are more holes that we're adding to that firewall, and our allow list is growing. And all of this is managed by the developers, and it's taking time. And at some point, we sit down and we say, we need to assess how this allow list is going. Is this system working for us? Is it scaling with us? And I start writing down these pros and cons. So a con for the allow list is it's difficult to manage. In order to update it, we need developers. Those developers have to deploy an update to a router, and that router then has to build, it has to deploy out, and all that takes time. And those developers are busy because there's features and there's bugs. So that's a backlog that just keeps growing. So that's not working great for us. It relies on consistent IP addresses. So the CEO out in the golf course, their mobile phone is dynamic, on a dynamic IP address, and it's going through, and it's just not able to have that one IP all the time. Sure, they've got a consistent IP at home. We can give them access from home so that they don't have to worry. But this stuff builds up, and it takes time. And our testers are having trouble with mobile testing, because again, they're on these dynamic networks, and this stuff just starts to add friction to the whole process. And the whole thing's opaque to non-tech people. That CEO, they're a fantastic CEO. As I said, they've leveraged COVID in order to grow that business. It's growing, it's making money, and it's doing fantastically. But they do people, they do business, and they do their job really well. They're not a developer, they're not a techie, they're not someone who has spent time understanding what an IP address is or what an allow list is, and the firewall doesn't really make sense to them. They just want to sit down, do their work, and sell the product. So this opacity is not great. It doesn't pass, what I think of as my parents' test. They're in their 60s, and they just don't understand these things. So if I have to get them to test something, if I want to get those third-party testers in, they're not going to understand. So not great. And now we're making the assumption that anyone connected to that IP address is allowed in, which seems like an odd choice. So I said we're working with consultancies now, and one of them is big consultancy. Big consultancy, by their very name, is big. They have a lot of staff, and they have a lot of customers, because we're not the only ones that are struggling to hire in this market. And the other day, you went to their office and sat down to do a planning session. You plunked down your laptop, connected to their Wi-Fi, flipped it open, jumped onto the staging environment to show them something. You didn't connect to the VPN, you didn't do anything else there, you just were able to because their IP address is allow listed. But Dave, who used to work for you in the consultancy, he's over working at the competition at the consultancy because they're hiring the same consultancy. Now, does that mean that Dave, who used to work for you, can still access your staging environment? Does that mean the competition can go and sit down in the consultancy office, connect to the Wi-Fi, type in your staging address, and start poking around your pre-market information? Probably does. And that's because IP address allow lists are not connected to a user account management system. They're just trusting that anyone on that IP address is okay. It's a trust-based network, and that's not really where we want to be. So what's in the pros column? The pros column is pretty much just, this is how we've always done it. And just because it's the status quo isn't a good reason to keep doing it that way. We want to grow, we want to improve, and we want to realize that allow lists suck, and there's nothing we can do to make them scale in the way we want to move in the future. So, the answer is zero trust networking. So, zero trust networking is built on top of 3 core principles. The first one is never trust, always verify. So we want to make sure that we don't trust someone just because they're coming in for an IP address. We don't trust someone just because they're inside a network. We verify that they are who they say they are. We check that they should have access to these things, because just because you're inside a network doesn't mean that you should have access to everything. I should not have access to your payroll information. This is just simple facts. I shouldn't be able to go in there and go, yeah, you get a pay cut this year. That's fine. That's not how we want to do things. We need to verify that someone has the access before they're able to do something. The second principle is that we need to assume breach. We need to assume that our network has previously been breached by someone, that there is someone who is a malicious actor hanging around inside our network, someone who shouldn't be there, someone who is going to try and do things they shouldn't be allowed to do. So we need to have good logging, good monitoring, good maintenance. We need to keep things up to date. We need to be aware of who's using what service and who should be using what service. Again, I should not access payroll. If I start suddenly accessing payroll, there should be alarms going off saying, hey, this isn't right. What's going on here? Someone should go and have a look. And I've done this before. Tried to log into something using the wrong password 3 or 4 times, and the next day security turns off my desk saying, hey, what's going on? Why'd you do this? And I said, I'm an idiot, and I put the wrong password in. I said, good, that's fine, go on. But they were checking, they were aware, and they had assumed that there would be malicious actors in the network, so they were checking on things that went wrong. The final principle is one that has been really well advertised by companies like AWS and Azure. It's selling this idea of adopting the least privilege. You should only have the privileges you need to do your job. If you need extra privileges, there should be a way for you to get them. It shouldn't be saying that you're locked down on some machine and you can't install VS Code. That's not what we're talking about. We're talking about saying that if you need access to production, you should be able to ask for access, get access, have everything that you do when you get to production recorded, have the reason that you needed access to production recorded. We want to make sure that if you're working in a company that has marketing and developers and call center people, that marketing and developers have access to staging because they need access to staging. They need to do that collaboration. But the call center, the call center doesn't need access to staging, at least not on there every day. The call center has no reason to go and see what next year's financial results are because that's not their job. What they do need to be able to do is make changes to user accounts. And the developers and the marketers should never be going and making changes to production user accounts. If there is times where those roles need to change, then great. We give them that privilege and eventually we take it away. And we do this all because we've assumed that we've been breached, so we need to adopt least privilege. We need to adopt least privilege because we don't trust anyone. We always verify they are who they say they are and they're trying to do things that they should have access to do. So with this model change, our network starts to look a little bit more like this. Each service is pinned off, has its own little protective layer, and the developers, the mobile testers, the marketers, they can all access our staging environment. Google, script kiddies, they can't access the staging environment. They're hanging out there on the side. They're getting rejected. And our little alien, who's been sitting there for a few slides now, is no longer able to have free reign within the network because they can't verify who they say they are. And because we assume breach, we're going to find them. We're going to kick them out and say, yo, no purple aliens here. This is a no alien workplace. And then the next question I think you're going to ask me, or at least the next one in your head, is, this is great, but how do we protect staging in a zero trust network if we don't have IPLR lists? Looks like we've got these little boundaries everywhere, and we need some way to secure them. And the answer to that is Openid Connect and Proof Key Code Exchange. So Openid Connect, or OIDC, is an extension on top of the OAuth2 or OAuth 2.1 protocols. OAuth2, OAuth 2.1, fantastic way to share your permissions with someone. So the idea of OAuth2 was that you would have a login to LinkedIn, a login to Gmail, and you would want LinkedIn to be able to go and read your contacts in Gmail to try and build up your network. You didn't want LinkedIn going and sending email as you. You wanted LinkedIn to send email as LinkedIn saying, hey, come and join LinkedIn. So you wanted to give LinkedIn the permissions to go and read your contacts, but not to send email on your behalf. Before OAuth 2, the only way to do that was to actually give them your login credentials and they would log in as you, and then you just trusted them to do things. But we don't like trust, so that's not a good idea. OAuth 2 gave us a way to give those permissions in a secure way. But it didn't give us a way to actually know the user's identity. That was sort of shimmied in, it worked well enough, but eventually smarter people than I came up with Openid Connect as a way to securely exchange information between two parties who don't particularly trust each other. And a key for us here is this uses an external authentication server. So I mentioned back at the start that you want your staging environment to be production-like. You want to be as close as possible to production, and you want to avoid anybody having an excuse that says, don't worry, it'll work fine when it gets to production. It's just staging. Staging is slow. Staging doesn't work properly. So we can't go and build some big infrastructure that just exists to protect staging. Because if we do that, staging will be slow, staging will be complex. It'll have all these reasons that we can just say, no, don't worry, that's just staging. Just go to production anyway. And that's how we get bugs, that's how we get problems in production, that's how we get outages, and that's how the CEO gets up there and is unhappy. And a key element of OIDC is it's going to allow you to know the user identity, so it's going to allow you to actually synchronize with your staff accounts. So one of the pieces of good news is that you probably already have a server inside your network that speaks OIDC. It might be called Ping Federate, it might be called Azure AD, it might be called Okta, CyberArk, one of any number of things, because Openid Connect is open. It's a protocol that anyone can implement. It's not particularly complicated to implement, and there are plenty of services out there, And if you're anywhere along the lines to zero trust, you've already got something that is a portal you log into, and then you click on that to get into Slack, and you click on that to get into AWS. And you have that in your system, but you just may not have thought to use it to protect staging, or you may not know how to. And I'll go through that in a minute, fortunately. So, proof key code exchange is the other part. This is the way that the flow actually works. So proof key code exchange, also called PKCE or PKCE, is a way for us to be able to do that exchange. So it goes back and forth between the two servers and gets that data across the line in a nice, secure fashion. It looks a little bit like this. Your client, they want to get onto stage.myapp.com. So enter into the browser, it hits your client says, I don't know who you are. I'm going to generate a proof and a key, also called a code verifier and a code challenge. Hit the wrong button. Proof and a key, code verifier or a code challenge. The proof just being random garbled data, just junk, something that when you generate again won't be the same. The key is a SHA-256 hash that's been base64 URL encoded of that data. And we're going to store our proof so that we can use that later. And we're going to take our key, we're going to put it into a query parameter and send it over to our authentication server. So I'll be using Auth0, but it could be anything of any number or one you even build yourself. Don't build it yourself. Authentication solves. Other people have done it and they can do it better than you. But we're going to send that over to Auth0. Auth0 is going to say, cool. I'm going to see whether I know who this user is. If they don't, they're going to push them through that authentication pipeline. So they're going to go through username, password, multi-factor authentication. We're all using multi-factor authentication in all of our apps all the time, please, yes. And we're going to take that. We're going to generate a code on Auth0. So that'll just be, again, random data, and we're going to store that proof. We're then going to redirect that user back again to the client with that code. So now our client has the bit of data it used originally to generate the proof, and it's got the code. It's going to take those, bundle them up, and post them in a post request back to Auth0. Auth0 is going to then verify that all this matches. So it's going to take the proof you sent over, SHA-256, base64 encode, URL encode it, and say, is this the same as the key they sent over earlier? Thus proving that they were the ones that originally requested the authentication. And they're going to take that code and compare it, and if the client has provided a client secret, they're going to verify that that matches as well. If all of that is correct, then they'll send back an access token and an identity token, possibly refresh tokens. Our client will then act on those and then log the user in. So all of this is an improvement on top of the authorization code flow that was available in OAuth 2.1. OAuth 2, OAuth 2.1 pushes for you should never use authorization code flow. You should always use proof key code exchange because you get that additional security. So if you were to do this as authorization code flow, you would log in, you'd skip generating the proof and key, you would then go straight to Auth0 where they would just generate the code, authenticate the user, send you back. You would do retrieving the proof, or you skip retrieving the proof, and then they would verify that you have that client secret. So you had to have client secret, which means that you couldn't do this from a mobile app, you couldn't do this from a web app. Finally, you would act on the ID token and redirect the user. So we just lose a bit with authorization code flow. It's a bit less secure, and generating it in PKCE, doing PKCE doesn't add a lot of complexity. So I'm going to implement all of this on top of my environment using Cloudflare Workers. Cloudflare Workers are a fantastic platform. They're up and coming. They are a serverless application platform, and they are really serverless. You can build entire applications in here without having an origin server. It's going to run on top of the Cloudflare Edge network, which is 250 nodes, well, more than 250. It was 270, I think, yesterday when I checked. It's probably 280 now. They're adding them every day. And they're all around the world. In Australia, they've got nodes in all the mainland capital cities. And when you compare that to what I think of as the competition with Azure and AWS, they've got data centers in 2 locations, Sydney and Melbourne, so you can get a lot closer to your workers, particularly if you are coming all the way over from Perth. They claim that Cloudflare has nodes within 50 milliseconds of 95% of the world's internet-connected population. So if you're running out there on the edge, you can serve things really fast to users right where they are, rather than having to go all the way back to origin servers and taking all of that time. These are also faster than Lambda. They spin up almost instantly. There's no cold start problem because they're working in a thing called V8 isolates. This is a web workers style environment where you're sharing an already running container. Fortunately, they've done a whole bunch of work to ensure that things are secure and that everything's working. If you are worried, you can go and read their paper on it. It's big, it's long, and Cloudflare are great at security. So they are willing to tell you why it's secure, and I can't explain it well enough. The thing that's going to catch you out, or at least the thing that caught me out, is this is a web worker environment, so it's not Node. It's JavaScript or TypeScript still, but it doesn't have all the Node APIs, so if you try and import crypto, try and import FS, it's going to blow up on you. It doesn't give you access to those things. It's much closer to a service worker, but really there's nothing you can't do as long as you don't need to write to a file system. And because it is in that environment, it gives you WASM out of the box. If you're a Rust head, if you're really keen on Rust or a few of the other languages, Go, they're available pretty much out of the box, running inside the inside of the WASM platform. And it's part of a whole platform, so in order to run it, you can use the console, but pretty quickly you're going to decide you want to use config as code because you're a good developer. So Wrangler is the CLI. It's a way to automate your config as code. It can run inside workers, inside actions, and it can do all your secret management, upload all that sort of thing without having to go into the console, copy and paste things, and do all that manual work that is error-prone and a waste of time, honestly. It's an NPM module, so you need to install at Cloudflare Wrangler. Don't install just Wrangler. It's another package, something somebody built years ago. Fortunately, they're not typo squatting. They're not doing a supply chain attack. They've put up a whole bunch of warnings saying, hey, this isn't what you want. Go and install at Cloudflare Wrangler. I know because I've made this mistake and was trying to work out why these things wouldn't work for me. In addition to just compute, Cloudflare have also added pages. This is a way that you can host your static page out on the edge network. Again, no need for an origin server, no need to go back to S3. You can run it all the way from out there. And this will work with Hugo, Gatsby, Create React App, just plain HTML, SvelteKit, any other fancy service that you want to use. It'll just work out of the box because it's just serving static assets. The platform also includes a thing called R2, one less than S3, or a pun on R2D2, I don't know. But it's a way to do object storage. It's S3 compatible. It's still in beta, but its big selling point is there's no egress fees. So if you're hosting big videos in S3, you'll know that one of those big costs is actually getting that data back out to your customers. This is a great way to avoid that entirely. They've got a durable objects option for in-memory storage. This does some really fancy stuff to provide transactional, low-latency storage across the world. It does this by moving that data around to where your users are and manages to keep it really fast and transactional, which is a bit amazing. But it's a paid feature, and I'm really cheap, so I haven't actually played with that. I have played with KV, which is even faster for reads, slower for writes. It's absolutely optimized for reading, it's key value storage, and it's cache-based. So it's going to put those values into the Cloudflare cache, and once you've read it once, it's going to be there for you to read, but it is eventually consistent. If somebody writes to it in Perth and you want to read it in Melbourne, you may have a little bit of time where you're still reading the old value. That's not really a problem if you're used to working that way. If you're not used to working that way, I think it's the way of the future, and it will make everything a lot faster. And it does have a very generous free tier, so I've had a bit of a play with that, and we'll have a look at it in a minute. So, the solution architecture that I'm going to put together here, or I'm going to show you, is a worker running in TypeScript, a GitHub action to deploy it, KV to store things, and an origin server that is none of your business, because that shouldn't matter. You should be able to have any origin server hidden behind your staging protection. It can be a big Java monolith, 1,000 .NET microservices, things written in Node, static websites. That shouldn't matter, because this should be independent of that, and it should be super fast. So I'm going to build just a really basic session store that hangs on top of it. But before that, you're going to ask me about pricing. So how much does Workers cost? Very little. Very, very little. There is a really generous free tier. So 100,000 requests per day for free. Up to 30 Workers groups. Up to 250 edge locations, or all 250 plus edge locations. Free Workers subdomains for when you're testing. And up to 10 milliseconds of CPU time. Now that's important. So I told you we don't want our things to be slow. So it means that everything I build in this demo will run in less than 10 milliseconds and add no more than 10 milliseconds to your execution time during your login. And because it is free tier, it'll have low latency after the first request, but that's fine. Our first request will be the user logging in anyway. And it includes some KV. So KV is 100,000 reads per day, 1,000 writes per day, 1,000 deletes, 1,000 lists, and up to 1 gigabyte of data. So if you're going over this, then the pricing still stays really, really low. For Workers, we're talking 15 cents per million requests per month. So really very little. If you're hitting that, then you're probably making enough money to afford it. For KV, again, 10 million requests per month for 50 cents. This stuff is really cheap, it's really fast, and there's no reason not to at least have a play with it. All right, let's have a little bit of a look at some demo code here. So, this is what the entry point for a Cloudflare worker looks like. It's going to listen, add an event listener, which is coming from the Cloudflare platform, and it's going to listen for the fetch event. Then inside the fetch event, in this case, I've got to do a little bit of type coercion because the typing is not going to work straight out of the box. But I'm going to create an event handler that will deal with all that, and eventually we just responds with the whatever handler returns. So, oh, sorry, yep. I knew there was something I forgot this morning when I was getting set up. That's what you get for having me come in at 9 a.m. in the morning. All right. So the next thing is going to be to actually set up that handler. Out here, we're going to grab the client secret, client ID, all this data which is stored in the global scope. It's put there through the Wrangler platform. It provides us with a way to do configuration based on environment and test things well. We've also got this auth store, which is a key value namespace that is also injected based on the config in Wrangler. So if we want to use something different for staging or something else, we can hook that up. Well, in this case, we're testing staging, but if we wanted to use it in a different application. So we have to type these to get them to work with Auth0, with Cloudflare. So just setting these things up as strings, and then the KV namespace is a type that comes from the Cloudflare package, and we just tell TypeScript that these things are available on the global namespace and what types they are. Our Wrangler document is using a markup language called TOML, or Tom's Obvious Markup Language. I don't know why everything needs another thing that looks like YAML, but apparently we do. So it's got a name, it's staging auth. We've got a type, JavaScript. We've got a zone ID and an account ID. So account ID is for everything under your login in Cloudflare, and the zone ID refers to the particular website that you're running against or domain name. And we set up a route, so it's anything that's going to stage.saladsimulator.com. We'll go through this. What's a salad simulator? We'll have a look at that in a minute. We're going to build it before it runs up, so the build command just says, hey, we're going to run npm install, npm build, and get all this working so that when we hit Wrangler publish, it knows what to do. And the format will be service worker. Here's those values that I said I'd set up. So this just configures the different things you need so that you can run this in different environments. And it shows how we have these 4 values that are there, but we don't have the secret. The secret was defined previously in the console. You can also use Wrangler to define them, but that keeps your secrets out of your GitHub repository, but allows you to have different things, and you can configure these per environment, so you can have them set up as production, staging, etc. And the KV namespace is set up here. Again, you need to create the KV namespace through Wrangler or through the console, and it'll give you these IDs, these GUIs that tell you about that storage. So, moving on, I've just got some very basic path-based routing in the handler there. A logout endpoint, a callback endpoint, and the session required handler. So the user will land into the session required handler. If they need to go out to log in, they'll go out to auth0, then get redirected back to auth/callback, where we'll handle their values. In here, we handle this request. So in order to set up the session store, I've got a cookie that's on the request, and we're going to check whether that cookie exists. So that's just sort of general browser stuff. Get cookie just gets the basic cookie off the browser, goes through, splits up the string, etc. Nothing exciting there. If there's no auth cookie, we redirect out to authentication and say, hey, this request, we don't know who it is, we need you to authenticate. But if there is authentication, if there is a cookie, we go to our KV namespace. So our auth repo, which has the KV namespace passed into it, just goes through and does this .store.get token and gives the type. The type is text. And then we pass it out as a JWT. So just got a header, body, and a signature. And if that's there, then we're good and the user can come in. If it's not there, we redirect to auth. And if the user can come in, we just call fetch. That's just the same old fetch you used to on the browser, and pass it the request that came in, and that'll go through your origin and then get returned back to the user. So if the user isn't authenticated, then we just redirect to auth. This is where the complexity comes in, but we're going to generate that code verifier. We're going to do that URL base64 encoding, the base64 encoded string over random code. Our random code is just a UNate array that's been filled full of random data. So random data just comes from getCrypto, which is just global this or window.crypto. So the same stuff you're used to in the browser, it's available there because it's effectively a service worker. So then base64 encode, that's just btower, good old fashioned btower. And URL base64 encoded just means that we're going to take all the plus characters, replace them with minus characters, all the slash characters, replace them with underscores, all the equals, replace them with nothing. And that will give us our code verifier. We then generate the challenge, which we'll just use that same
library from crypto from the browser and pass through to SHA-256. Then we just take that buffer that's returned and do URL base64 encoding on it again. And that gives us the value that we want to send to Auth0. So build up that URL, just adds a response type of code that's required. So that's for authorization code flow or PKCE. The client ID, the redirect URL, so where it wants to come back to after it's logged in. The audience that we're asking for, the scopes have to at least be Openid Connect and profile, or Openid and profile. We're adding that code challenge, so that's our SHA-256 hash, and the code challenge method has to be S256. The spec does provide support for symmetric hashing, but we don't want that. We want to be S256, and that's the only one Auth0 supports. So we'll bring that over, and then we just set a couple of cookies. So we're going to store our code verifier as a HTTP only cookie. And we're going to set it to redirect 302 to that URL we just created. We're going to set an additional cookie, which is our callback URL, because I want our user to end up where they wanted to go in the first place. And finally, we return that, which will bring it back to that top handler and send the user over to Auth0. At Auth0, they're going to spend their time, do their thing, do their MFA, and then get redirected back to here. Here, the URL is going to be parsed out, and we're going to grab that code. So it'll come through as a request parameter. And that code will just be short, sort of 6 or 8 characters, and will be sent back to the client, back to Auth0. We're going to get our cookie from our code cookie, which will have our random string in it. And then we're going to go back to Auth0 and exchange our code for a token. So I'm just passing fetch in there because it makes everything easier to test if you don't rely on the browser APIs directly. So this is going to be a post request. Type is authorization code. It's going to have our client ID, our secret, our code verifier, our code that came from Auth0, and our redirect URI that we used in the first place, because we need to make sure that's just one of those other things Auth0 is using to check to make sure we are who we say we are. And then our audience in our scope so that we get the right values. We'll ping that off. It'll come back through, and presuming everything's okay, which it should be, we'll just parse out the response, and that'll be a token response. So in this case, it'll have an access token, a refresh token, an ID token, and a type. We can then use that here. Let's go back to that. We can then use that here, decode it so that we can see that the ID token looks how we want it to. We don't necessarily need to validate it here because we have gone through using the post request to a known endpoint. This isn't a token coming in from an untrusted location. I'm then going to take that plain string token, I'm going to hash it, and save that into the repository. So that becomes our cookie and it becomes our key. So we don't have to do that hashing every time. That's just done once on the first login. And then from here on out, we just have to check whether it exists. We're also going to use the expiry from the parsed token to set up a lifetime for this session. So now Cloudflare will take care of deleting that after the token expires, and we now have a time-based sessioned auth that exists without us having to do any work on each request. So that we're in our auth repository, we're then just going to get our cookie, set up a request that uses it, and we're going to set our auth cookie with our hash token as the value, so that on every request we can see that's there, pull it out of the cookie, check whether it exists inside the repository, and validate that our user exists. So we never trust our user, we're always verifying who they are. All right, and the last thing is just to make sure we can actually deploy this into production. So it's really complicated right here. This is the build and deploy GitHub workflow you need. You just need, when you push to main, then run this one job, and it takes care of everything for you. It's a Cloudflare API token you've got to get from the console, put it into the secrets in GitHub, but other than that, the Cloudflare action will take care of everything for you. Deployment is as easy as that. So you get basically free deployment, free security, and without having to do a whole lot of work. So, told you I'd tell you what Salad Simulator was. So, what is it like to eat salad? Maybe it's dire. Maybe it's just sad face. This came out of one day, I was at the pub, I was trying to eat healthy, everyone else is eating burgers, schnitzels, wonderful looking food, and I'm sitting there with a pub salad. And I just felt sad, so I thought I should make a stupid website about that. But I'd love for my stupid website to be more popular. So I want to do a collaboration with a guy called Nigel Ng. Nigel Ng has a character called Uncle Roger. Uncle Roger famously does not like vegetables. He thinks they taste like sad. So I've started to set up a little bit of an example page about how we could work together, how everything could be fantastic. But I don't want anyone to see it just yet because it's still a work in progress. So if you go to stage.saladsimulator.com, you'll be redirected to this Auth0 login page where we can log in using the very secure test at mailinator.com. If you don't know what Mailinator is, you should look it up. It's a fantastic service. And it's got a really secure password, which is PASSWORD1. Super secure. You can go and log in and try it out for yourself. So now, I've got Nigel there. He thinks vegetables taste like sad, but I think my web design skills also taste like sad, and maybe I need to do a little bit more work before I start talking to an international comedian about getting onto my joke website. So we might just leave that one secure for now. All right, cool. So with that, we're running close to time. We should finish up. So I have gone through here, had a bit of a talk about zero trust environments where we are always going to verify people. We're never going to trust them. We're going to assume that we have been breached and that people shouldn't be allowed to just go willy-nilly within our system. We need to make sure that we're keeping little purple aliens out and that people are only doing what they need to do their job. And we're going to do that by adopting least privilege across everything. We know that IP allow lists are a problem. They're hard to maintain. They're open to abuse. And we're going to solve that by adding in Openid Connect and proof key code exchange. So we're going to use our existing providers that exist within our network that are synchronized up to our systems that say we are secure because we know these are our current users. When our users move to work to the competition, their accounts disappear and they can no longer access our staging environment or anything else for that matter. It's open, so you can jump in and you can use any number of things, but Okta, Auth0, Ping Federate, Azure Active Directory, all of these things are great ways to make sure you keep your system secure. And because it is open, a whole lot of things can actually talk to them. And that gives you access to making use of that federated identity. And I showed you a little bit about Cloudflare and how it's an emerging and already capable application development platform where you can build little things like this, but you can go a lot bigger and build your entire application without needing an origin server. I showed you how you can build a really basic session store that sits on top of your staging environment to protect things. It used workers for logic, which were running in JavaScript, but could be running in WASM. And it used KV for storage, which is a fantastic, really fast, lightweight system. Again, that whole thing, reading from the database, writing to the database, it's going to take less than 10 milliseconds on each request. So it's not adding any time. And with that, that's about everything I have for you today. I want you to remember that IP allow lists suck. And if you are interested in having a look at that code, it's up there on GitHub. or you can hit me up on @KLEEUT, and I can point you to it anytime. My DMs are open there. All right, thank you very much. I've got a couple of minutes for questions, I think, or I'm happy to talk to you. I'll be around all week. Hello.
So is there advantage to implementing it yourself versus just using Cloudflare Access directly?
Probably not. Okay. You're probably able to, I can play with Cloudflare Access, but if it's going to work for you and work with the correct accounts, it sounds like a good idea as a general rule. You probably shouldn't build any authentication yourself if you don't have to, because it's not what your customers are paying you for, right? I really like to push everyone towards Auth0 or other things, because no one ever goes to your software to say, hey, how good is the login system? You're there to deliver value, and authentication is plumbing in the end. Right. Other than that, I'm going to go and get a coffee. So, thank you very much.